Hello, everyone. Let's get this session started. So today we have two speakers on stage coming over to talk about data archaeology. I have no idea what that term means, but this is Vicky Antonova and Elliot Schmuckler. Welcome.
Thank you.
Thank you so much. Can everyone hear me okay? Yeah, all right. I'm just testing your interaction skills. Who can raise their hand? All right, you're all awake. You passed the test. So I'm going to answer the first question first, is what is data archaeology? So probably when you read the title of this talk, you were thinking about, going deep into the jungle somewhere, finding a lost city, digging with your laptop to uncover artifacts, right? So I had Midjourney generate an image of a data archaeologist here. Hopefully what you envisioned in your mind when you read this talk. But actually, what data archaeology is something that comes out of a basic insight that everyone who works with data realizes, right? Before you can use any kind of data set to do all the things that we do with data, get insights, build models, detect issues and trends in the data, you have to have a foundational understanding of what that data set is like. You have to have a basic understanding of the basic structure and characteristics of that data set. All right? Everyone with me still? Yeah? See some head nods. So that is what we call data archaeology. It is the process of understanding the basic structure and characteristics of typically unfamiliar data sets so that you have enough foundational knowledge about that data set to actually start using it for something valuable, right? So you can imagine this is like digging through the data to understand what's in there, hence the archaeology. But you're kind of digging with your SQL queries maybe instead of your laptop, I don't know, or a shovel. So we're going to talk about data archaeology today, and we're going to give you different ways of approaching data archaeology. An old way, something that you're probably used to now if you explore new data sets, and a new way using Anomalo, which is the product that Vicky and I work on. And so hopefully you come away seeing that there are better ways these days to do data archaeology when the time arises. But before we actually show you how things work, we need a good data set that we're going to dig through. So I'm going to introduce the data set that we're going to use for our talk today. And it's a data set you all can play with. It's a publicly available data set. It's from the GDELT project. This is a Google-sponsored project where it gathers all of the press coverage around the world into a single data set. And it gathers this press coverage and also classifies it in a bunch of different ways that are interesting for the exploration of this data. And we're primarily going to use its online news data set. So these are articles published on the web from all around the world. And so you can see what this data set looks like. Basically, for every article that comes out, there's a URL on the right, and the GDELT folks have done some work to extract entities and to score this article. So for example, here's an article about the South Sudan Civil War, right? And GDELT has done the work to figure out, well, which countries, right, which regions of the world are involved, are mentioned in this article. And they've also computed some sentiment analysis about this article. That's in the average tone column. Is this a positive article or a pretty negative article? And as you may expect, a Civil War article is a little negative, right? Hence the -4 here. And they've also computed some popularity statistics. How many articles around this topic have come out around the same time? Right? So it gives you some interesting information about articles for you to explore. Now, what's great about this data set is, unlike probably all of your data sets, it comes with documentation. And in fact, it has 11 pages of documentation. Who here has a data set with 11 pages of documentation or more? Oh, yeah, wow. Wow, yeah, 2 of you. So mostly none of you have your data sets this well documented, and it's pretty unlikely that the next data set you need to explore and understand has this level of documentation, or frankly, at least speaking for me, that you're gonna read all 11 pages to understand where it's going on. So we're gonna give you ways of doing data archaeology without having to read 11 pages or having documentation in the first place. And so when we're doing this exploration of the data set, when we're doing this data archaeology, these are the questions we're gonna be asking. These are the foundational pieces of knowledge we wanna develop based on the data set that we're exploring. How much data is there? Is the data getting updated? What are the column types and values? What are the distributions of the values? How do the columns relate to each other? And finally, are there interesting trends in the data? And so we'll show you ways of, we believe these are the fundamental data archaeology questions that you should always ask, right? That you should know about your data sets, the data sets that you're about to use. And we're gonna show you some ways to very quickly get answers to these questions. First, I'm gonna show you the old way. And then I'm gonna ask my colleague Vicky to come up and show you the new way, because I'm old. Oh, I gotta laugh. So the old way kind of looks like this on the right, where you're staring at your screen in frustration, because really what you're doing is you're opening up a SQL client and you're gonna start to query the data, right? And you're gonna try to look at it, and you're gonna do query after query to figure out what's going on. And so you might start with something very simple where, let's just get 100 rows from this data set, see what they look like. Who's done a query like this for an unfamiliar data set? Yeah, all of you, yeah. Yep, looks great. You got 100 rows, maybe you can learn something from the data set about that, but not a whole lot. First of all, you got, a random 100 rows selected by the data warehouse. Who knows where they're from, right? I don't know if they reflect recent patterns in the data or if they're representative of the data at all. So probably, you then move on to something fancy where, we're gonna select some recent data, right? And we're gonna figure out how to get data from the last month or so. And maybe we don't want just a random 100 records selected by the warehouse. We actually want, statistically selected representative records, right? So we're gonna order by a random number so we can get good representative records from our data set. And 100 records is not a lot to understand the data set. We probably need 10,000 records, right? So now you're really getting into it. You got a representative sample of 10,000 records in this data set. This is gonna be great, but of course you now have 10,000 records. So are you gonna look at them by hand and try to summarize them? No, you probably need to throw them somewhere else where you can explore them. You're probably thinking, well, I gotta boot up my notebook and use my Python or something to summarize these records, right? So you're doing tons of work here to do this data archaeology. And query after query, you're learning things about your data, but it's definitely a lot of work. And if you wanna go even deeper, well, maybe you wanna explore article distribution by country. And so now you have to figure out how to do that, and we're gonna use recent data, and we're gonna group by this column that has a country in it, right? And we're gonna get the most popular countries. So you see what I'm talking about, right? This is the old way. This is how probably most of you are used to exploring new and unfamiliar data sets. And so what you're actually doing here is, to borrow an old expression, is you're being a SQL monkey, querying the data in the hopes of getting the results that you want, right? And in the hopes of really learning about the data set. And so instead of doing that, we'd like to show you a new way of doing this, which is how you can use modern tools like Anomalo and what they're able to do automatically through machine learning and kind of automatic querying of the data to get you to the end state of really understanding your data set and finishing up your data archaeology. So to tell you about the new way, I'm going to invite my colleague, Vicky, to come up.
Thank you, Elliot. And thank you for the walk-up music to whoever that was. So let's talk about what this new way could look like. If you kind of step back, you can think of it as 3 steps that you can go through when you're doing data archaeology. The first step is to profile automatically. So basically, everything Elliot just showed you, how can you do that without querying the data over and over again, or having to think of which queries to run, or copying and pasting queries from your previous analyses? The next step is to automatically monitor for changes in the data. Now, why would we want to do that? If you think about what insights in data really are, there are changes or interesting trends about the data that you didn't think were there or hadn't found before. So what better way to find those than to monitor for changes in the data and get alerted when those happen? And the last step is to root cause these changes and understand exactly what happened. So now you're actually finding the insights. And if you can do that automatically, even better. So let's break this down. Let's go into step 1 first. Profile automatically. So in this case, I'm going to use our tool Anomalo to help me with the automatically part. But you can imagine you can use or create a tool internally even to do that. So here, we have our table homepage for our GDELT table. You can see that across the top. And we actually, our bread and butter is data quality monitoring, but we're not going to worry about that right now. I'm actually just going to go in. I'm going to paste in that 11-page document that Elliot showed you in case someone after me wants to read it. And I'm going to select all the defaults here. So doing this turned on data quality monitoring for this table. But again, we're not going to worry about that just now. Instead, we're going to scroll down in this page and see what the data looks like. Now this one appears right under that table homepage, and it's Elliot's select star limit 100 query. So this is a screenshot, but you can actually grab that blue dot and scroll through and kind of understand what is happening in the data, what the records look like, and begin to build intuition behind it. But that's not really enough. I need to understand a little bit more about the data. Let's keep going down our question list and see how much data there is and if it's fresh. Now in this case, again, scrolling further, I will find this graph. You can see these are the records over time. On this particular date, this was June 1st, you can see there are around 250,000 records. And then maybe you'd be tempted to just end there. There's actually a lot more we can learn from this graph. If you zoom in, you can see there's quite a bit of day-of-week seasonality. Now that makes sense. Remember, these are articles that are published, news articles that are published every day. So on the weekends, fewer articles. During the work week, there's a lot more that go in there. You can also see that back in the end of March, beginning of April, there was a big jump. There's almost a stepwise jump in there. So what could that be? Were there all of a sudden more reporters writing new articles? Were there more news around the world? Probably not. It might mean that this public data set got a new source ingested in there. So you might want to know that when you're providing analyses and sharing those widely. And finally, this missing data on, was it March, let's say March 20th here. On this date, again, if you were to include this in your analyses, it might skew your statistics if you're doing any sort of average for the month of March or anything like that. So you might want to know that actually maybe it wasn't that there were no news on that day, but there was some sort of outage that seems to have affected all your sources. So scrolling down further, again, all of this is happening automatically. You can find the column types and values, the top values for them. So on the y-axis, you will see the different columns in there. In the middle, you'll see their database types. And then these graphs on the right-hand side are the top values that are occurring. Now, for those of you in the back, let's zoom in a little bit. So you can see those actor 1 and actor 2 columns. Maybe let me explain, because I did read the 11-page documentation. What GDELT is doing is breaking down each one of these news articles and saying, 1, who the initiating actor is, so who did something to someone else, and 2, who the receiving actor is, who is on the receiving end of that action. So here you can see that the US, maybe not surprisingly, dominates the news. And then further down, you can see some statistics, as Elliot briefly introduced them as well. So there's the average tone of the article, there's a Goldstein scale, which is a conflict resolution code, and then there's some popularity statistics in here. Now again, you can see some of the most common values, but that's not quite enough to understand what's happening in those columns. So let's keep scrolling down. Further down, you can see the distributions of values in those columns. Now, especially for those numeric columns that we were just looking at, that's really helpful to kind of build an intuition between how those values move or look on a regular basis. Zooming in just a couple at the top for those of you in the back, I did not lie to you. This is the mode of all of those actor columns. The US dominates the news in all of these articles. But another thing you can see that in our sample of 10,000 rows, those actor 1 and actor 2 columns have over 1,000 unique values in there. So if I were to do something similar that Elliot did and break those down by country or by actor 2, I would need to manually interpret, even if I had an auto way to graph each one of those, I would need to manually interpret thousands of different time series visualizations to understand the trends for them. Now, farther down here, we have our statistics on the numeric columns. We have a min, median, max. We actually have a lot more percentiles. I just couldn't figure out a way to include those in this slide. But you can really build an intuition. You can see that the average tone for all the news articles, the median tone for all the news articles is negative, maybe not surprisingly so. And another cool thing that happens here is that we auto-detect, you can see those columns that have full name in them. We auto-detect that some PII is included in them, and those are flagged. You can see that we infer the people names are included in there. And then finally, our final scroll down through, again, without me writing any of Elliot's queries, is how do these columns relate to one another? Now, this graph might be intimidating to interpret at first, but even if you don't know how to read the dendrogram on the right or are familiar with these correlations, there's a lot to learn in here. So if you lean back and squint at it, hopefully you can see there are 4 distinct squares in there. So there's the first one, which is the ID and time correlated columns. There's the second one, that are the article initiating actors and receiving actors. Now this is cool because this is these are all categorical columns. And normally you can only really do correlations on numerical columns or do so quickly. So we use the 5K correlation in order to cluster both numeric and categorical columns together and represent those together. Now it makes sense. Certain types of actors are more likely to occur in the same articles with different ones. So that's why all of those are clustered together. And finally, you have the article actions, so the average tone, the event code, and then the article popularity statistics. So we went through step 1 pretty quickly. I didn't have to write any additional code. And I could build some intuition behind the data. I know the column types, I know the distributions, I know how they relate to one another. So now I can start thinking about what types of questions I want to ask of that data. So I will come back to this table homepage. And in this key metric, I'm going to add a new key metric. And I'm going to add the key metric that Elliot created earlier, looking at the breakdown of article counts across the actor 2 types. Now, I'm going to select this is a segment custom SQL metric for long living segments. Remember, there were thousands of these in there. I'm going to ask it to pick out the most important ones, looking back in the last year. I'm going to select our column, actor 2 name. I'm going to select our metric SQL. I'm going to look at the average tone, actually. This is what, instead of the count, I'm looking at the average tone of the articles. And then I'm going to save and run this. Now, if I were to click in, I would get this visualization for the top 100 segments in there. The green bar represents the 99% confidence interval of where we think the average tone would fall into. And the gray dots are what actually happened on that day. And you can see on that day, there's actually something interesting happening here in the United Kingdom. So the average tone in the articles is above where we would have expected it to be. So again, going to click in here. And that brings us to step 3. How do we root cause these changes? If I click in there, I will get this time series view of getting the history of the statistics over time. You can see that articles, like the rest of the articles in the world, are quite negative in the UK. But starting around the end of April, there's this upwards trend until finally on, let's say, what is this, May 6th, it peaks out at the top. Now, how many of you know what happened May 6th in the UK? There's one. Let's see. So these are actual articles from that day in the UK. We'll vote, since all of you know how to raise your hand, and Elliot checked already. So how many of you think it's number 1? Robot vacuum cleaner escapes from Cambridge Travelodge. No one. Number 2, zoo separates 5 parrots after birds were caught encouraging each other to swear at guests. My personal favorite. I personally think it could improve the average tone in the news. Number 3, the King Charles coronation. All right, we have a popular one. Let's see number 4. Man fined for pretending to be a ghost at cemetery. That's right, I love it. So you guys guessed it. It's number 3. It's the King Charles coronation. And that is probably, when it comes to root-causing issues, that's probably one of the easiest I've done before. Usually you can spend days or even weeks trying to understand what is happening in the data. But I got excited about the theme of the royals and decided to set up my first SQL query, and that is because I wanted to do it all in one place. But I decided to look at these article metrics, popularity metrics, average tone, for this data set for all the royals. And the cool thing about doing this using a tool is the fact that I don't now have to go and redo this data archaeology piece next month when the data changes. I will monitor it automatically using step 2, and then I'll get alerted if new things happen or shifts happen in the data. In fact, this was completely unscripted. That's exactly what happened to me just a couple of days after. I got a new alert in Slack. Now, in this case, you can see that the number of sources with receiving actor equal to Prince shot up. And I got the familiar peak around, May 6th. But there's a smaller peak, there's a smaller peak on June 5th as well. Now, I don't really know much about the royals, but I knew there wasn't another coronation. So I wanted to understand better what is happening here. Again, I clicked into it. This, because I set these up all together, allows me to see how these metrics are moving in relation to other metrics. So here, you can see that peak in the number of sources talking about royals for all of the royals. But you can see that there's only a peak, There's only a peak at the end for the case where it's equal to Prince. Similarly, on the average tone, you can see that the average tone for the rest of the royals is pretty steady at the end, but it only drops for sources where it's equal to Prince. Now, again, I wasn't sure what's happening here, not super familiar with the royals, so I just typed into Google Prince UK on that day, and this is what came up. I went down a rabbit hole, but as it turns out, Prince Harry is looking for some extra security detail and is really not happy with the media. So that allowed me to get an insight that I wouldn't have gotten out of that data. So in summary, for all of this, I had never seen this data set before. I got to get familiar with it. I got to ask it questions that I was interested in by just writing one SQL query. All of the rest happened automatically. So I'll let Elliot bring us home.
All right, thank you so much, Vicki. It's kind of fun to realize that the way you get positive news coverage in the UK is to have a big coronation party. Other than that, it's all negative all the time. So, good insight. Anyway, hope this was helpful. Hope you learned some things, some new approaches and new techniques. And I hope the next time you have to do data archaeology, you won't be a SQL monkey anymore. But instead, through this talk, your mind has grown, has been expanded, you've gained insights, and so now you've seen the light of how to do data archaeology the new way, how to do it quickly and without writing hundreds of queries, and how to learn more about the data sets that you're working with. Thank you very much.